Okay, a polygon. Don't write this where it says the definition of polygon. This is not the definition yet. This is just a FYI, like, okay, let's figure out what the word polygon means. So, poly means many, and gon means angles. So every time you see polygons, you're saying many angles. Many angles. So what does many mean? How many angles does a polygon have to have anyways? Can a polygon have one angle? No, right? At least 3, good. Polygon can't have 2 angles. Try to draw a polygon with 2 angles. Doesn't work. Yep. So when they say many, they're saying 3 or more. Polygon, many angles. Here's some examples. We got a soccer ball made up of pentagons and hexagons. We have obviously our road signs, a stop sign, a yield sign, whatever those other signs are, speed limit sign. Stained glass a lot of times is made up of all different shaped polygons welded together. Quilts are often sewn from different pieces of fabric polygons. All right, here's the actual definition. We did learn this last semester, but we didn't really talk about it very much, so I'm pretending like we never learned it before. A polygon is a closed, plane figure with at least 3 sides that are segments. So first and foremost, it needs to be closed. That's why this one right here is not a polygon, because they didn't finish it off. They didn't close off the side. That one's open. It has to be a plane figure, which means it needs to be 2D. 3D shapes are not polygons. A segment is not a polygon. It has to be 2-dimensional, 2D. It has to have at least 3 sides. We talked about why. And the sides have to be segments. No curves allowed. It's like a crescent moon. That would not be a polygon. It has to have segments for sides. So we've got a polygon, not a polygon because it's not closed. And then this one's not a polygon because the sides are not allowed to intersect like that. So that's 2 polygons. That's a polygon and that's a polygon. But I don't want you to think that whole shape is a polygon because it's not. Polygons can be categorized into concave and convex. Most of the polygons you're going to see, and rather most of the polygons you're going to work with, are convex polygons. So convex polygons are the ones you're used to seeing. You know that they are convex because when you draw the diagonals, when you connect a point to a point, all of the diagonals fall inside the polygon. None of them are outside. A concave polygon, on the other hand, is like you took a side and you caved it in. So when you draw the diagonal from P to Q, that dotted line, that diagonal fell outside the polygon. So that's why that one is concave. I want to go back real quick. This one right here, you see this shape on the quilt? That shape, that tealish, bluish, aqua, that shape is a very concave polygon. A lot of the sides have caved in. It just looks like someone kind of pushed them in and they're jutting into the figure. Okay. Is the figure a polygon? If so, is it convex or concave? We did this last semester, so I'm going to go through it really quickly. This one is definitely a polygon, but since the side has caved in, it is concave. This one is not a polygon because the sides are not allowed to intersect like that. This one is totally a polygon, and it is convex. All right. Okay, we went over this last semester as well, and that word showed up on your test yesterday, didn't it? An equilateral polygon means all sides are congruent. That's what lateral means. Equilateral, equal size. An equiangular polygon has congruent angles. All angles are congruent. Equiangular, equal angles. So a regular polygon, which we are going to focus on a lot in this short little unit, is a polygon that is both equilateral and equiangular. It just means all sides are equal. Put tick marks on them. All angles are equal. Put arcs on them. Here we go. We're going to go through these shapes one by one. We're doing this so that we can name them and so we can talk about their angles. Today is all about the angles of these polygons. All right, here's a polygon we know really well. It's a triangle. It, of course, has 3 sides. This is not going to make a lot of sense yet. A triangle is made up of one triangle. How many degrees are in a triangle? Of course, 180. And then if it's regular, be careful, this only works for regular polygons. If it's regular, what is the measure of one interior angle? Yeah, you take 180, you divide it by 3, because if it's regular, they're all congruent, and one interior angle would be 60 degrees. Okay, next one, a quadrilateral. Now, a lot of you might have already memorized how many degrees a quadrilateral has in it, right? You already know it has 360. We've used that a little bit. We used it last unit a little bit. But what I mean by number of triangles is that if I were to draw all the diagonals I could from one point, so I pick one point, I'm going to draw every diagonal I can draw. Well, that's not a diagonal. Okay, there's a diagonal. That's not a okay. So when I draw all of my diagonals, I create triangles. And I happen to create 2 triangles. Now each triangle is going to have 180 degrees. So that's how we come up with how many degrees are in a quadrilateral. We divide it into triangles. There's 2 of them. 2 times 180 is 360. Now, what would it be called if my quadrilateral was regular? What would it be called if my quadrilateral was regular? Now be careful, someone said square or rhombus, but to be regular, you have to have all sides congruent. Okay, I agree, that's square or rhombus, but you have to have all angles congruent too. Regular is all sides and all angles. Okay, so if it's a regular quadrilateral, it's a square because it has all sides congruent, all angles congruent. So what's one of its angles? It's 90. So my picture up there is not a regular polygon. It is not. Okay, what's it called if it has 5 sides? Pentagon, and we have a Pentagon in the U.S., right? A government building, and it is called the Pentagon because it's actually shaped, bird's eye view, shaped just like a pentagon. It's pretty cool. All right, a pentagon has 5 sides. Now, if I were to pick one point and draw all the diagonals I could, how many triangles would occur? 3 triangles, right? Okay, so a pentagon can be divided up into 3 triangles. Each triangle has 180 degrees. So the sum of the interior angles, yeah, there we go, 540. Now, if my pentagon is regular and it has 540 degrees, well, I want to know the measure of one of the angles. 540 divided by 5. Very good. So you take the number of degrees and you divide it by the number of sides. Okay. What's it called if it has 6 sides? Y'all can use your mics. Yes, 6 sides is a hexagon. Are you seeing a pattern here between the number of sides it has and the number of triangles formed? A pattern between the number of sides and the number of triangles formed. Because that's actually very important. Good. Every time it's -2, right? If it had 3 sides, there was 1 formed. 3 minus 2 is 1. If it had 4 sides, there were 2 formed. 4 minus 2 is 2. 6 sides, 4 formed. 6 minus 2 is 4. So every time the number of triangles is 2 less than the number of sides. Very good. 4 times 180 is 720. And 720 divided by 6 is 120 degrees. Woohoo! Moving on. Heptagon. Heptagon has 7 sides. Remember, sometimes you might see this referred to as a septagon, so you might want to make notes of that just in case it shows up that way. Of course, there are 7 minus 2, 5 triangles. The sum of the interior angles, 900. and one interior angle is ugly, 900 degrees. We're going to keep it as a fraction unless Miss Tanton gives us permission to round. Okay, I'm going to go really quickly through the rest of the table because the table is not what's important. In the table, we're just finding out a pattern that's occurring. So our next one is octagon, like an octopus, like a stop sign. An octagon has 8 sides, of course. Sum of the interior angles is 1080, and one interior angle is 135. What's happening to our one interior angle as our sides get bigger? What's happening to that angle? Okay, so we are saying as our shape gets larger, these angles are getting bigger and bigger and bigger, aren't they? What's the biggest that that angle is going to be allowed to get? It's increasing more and more as our shape gets bigger. That's true, Aaliyah, that's true. 180 is the maximum. Can you have a polygon with an angle that measures 180? No, because that wouldn't be a vertex, right? Yep. As you add more sides to these, as we keep adding more and adding more, what shape are these approaching? Do you understand what my question is? As we're adding more sides, there you go. It's approaching a circle. Yep. And you'll learn about that in pre-cal. You'll learn about limits. And as the number of sides gets bigger, it approaches infinity. As it approaches infinity, the shape approaches a circle. It's pretty cool. All right, nonagon. That's how you pronounce it. Nonagon. 7 triangles, 1,260 degrees rather. And one interior angle is 140. So if it's regular, it means all of these are 140, 140, 140, 140, 140, 140. All of them, all 9 of them. We are skipping 11. Don't really know why, but we're skipping 11. And we've got decagon, because we don't really memorize the name of an 11gon. So a decagon has 10 sides, 8 triangles, 1,440 degrees, and each angle is 144. 12 square degrees. Decagon, like a decade, 10. When we do skip 11, our next shape is called not a decagon, but a dodecagon. It makes me think of Sound of Music, like doe, a deer, I don't know. Anyways, a dodecagon. I can't say that word without thinking Sound of Music. All right, 10 triangles, 1,800 degrees, and one interior angle is 150. All right, guys, so we are not going to memorize this table. That would be ridiculous. You're not going to walk around with the table in your pocket. So instead of having to look at a table every time you want to know the angles of a polygon, we're going to need a formula. So we're going to need a formula no matter how many sides a polygon has. Let's say it has 29 sides. I want to know how many degrees are in that polygon. So what could I do? What would my formula be? The table has been approaching this. I'm going to call the number of sides n. How do I find the degrees if I know the number of sides? Oh, good. So Leah's saying find out how many triangles are in it and multiply that times 180. So if my shape has n sides, how many triangles does it have? Good. It has the number of sides minus 2. We found that out by the pattern we created in our table. And then you take n minus 2, that number, and that's how many triangles you have. You multiply it by 180. So there, write it down. Very important formula. The sum of the interior angles can be found by the formula n minus 2 times 180, where n is the number of sides. Okay, and then if we wanted just one interior angle, we would take the same formula right here. Oh, it's all piece. We would take that formula and we would divide it by n. Very good. Yep, you both said it. You were both right. So same formula. Don't be scared. It's the same thing. You just divide it by however many angles it has, however many sides it has. And that's what n is. So if it's a dodecagon, n is 12. If it's an octagon, n is 8. Okay, now we're going to move on from the interior, the orange ones, XYZ, and we're going to move to exterior angles, the pink one, the pink XYZs. Now, what's really important for you to know is that an exterior angle is formed by extending a side. Kind of sounds like extend, exterior. An exterior angle is formed by extending a side. So let me show you what an exterior angle does not look like. A is not an exterior angle. I did not extend, I did not lengthen a side. I just stuck a segment out of that angle. No, that one has nothing to do with what we're about to learn. So do be careful when we learn what we're about to learn. The exterior angles are created by extending a side. I think I said that enough, right? All right. In order to discover what the sum of the exterior angles is, we have to know how many degrees are in a circle. Good. There are 360 degrees in a circle. So why is Ms. Tanton asking me this? All right, so I'm going to show you a cool little demonstration. Okay, so I have a triangle right here. It's probably an equilateral triangle. It looks pretty nice. Those purple arcs, the fan, represents the measure of an exterior angle. Now, when I make the shape bigger or smaller, it's going to be a similar shape, right? So as I shrink this shape, which is what I'm about to do, I'm about to shrink it, it is not going to change the angles. It's going to change the sides. It's not going to change the angles. So watch what happens. Oh my goodness, what can you conclude about the exterior angles of a triangle? What can you conclude? Yes, they add up to 360. Now, you're like, okay, well, that's a beautiful, nice equilateral triangle. Of course it does. Well, I can, maybe, if it lets me. Come on. I'm going to have to go sit at my computer and use the mouse because it's more precise than me touching the smartboard. I can move the vertex and make it not an equilateral triangle. And look at this, wait for it, wait for it. Whoa. Even though those angles are different measures, they still add up to 360. Okay, so that's good. That's for a triangle. They add up to 360. Now let's try, what's this? A quadrilateral. Now let's see what happens with a quadrilateral. Oh my goodness. Oh my goodness. The same result. No way. Okay, let's add another side. Now we've got a pentagon. Whoa. Mind blown, people. It's coming up with the same result every time. How many sides do I need to do to convince you? Oh, we don't want it to be overlapping. I'm running out of space here. All right, how many sides do I have? Quite a bit. Even though all the angles are different together, I promise, so cool, they form a circle. So moral of the story is that the sum of the exterior angles, we don't even have a formula for that. There is no formula because it's 360 all the time, for every polygon in the world. Cool! The measure of one exterior angle would, of course, be the same as the other one. You take the sum and you divide it by the number of sides. 360 divided by n. All right, let's try some problems. I think we're ready. Find the sum of the measures of the angles of the given polygon. So when you're asked questions like these, you have 4 formulas. You're not required to memorize the formulas. You just have to pick the right one. So I see sum, and then when you don't see interior or exterior specified, it's always interior. So when it doesn't say, it's always interior. Okay? When it doesn't say. All right, did you do it? Use your brand new formula. Try it on. N minus 2 times 180. 28 times 180. Okay, just kidding. All right, so the answer is 5,040 degrees. As the shape gets larger, the sum of the angles gets larger as well. Okay, next one. If the sum of the measures of the angles is given, how many sides does it have? So we are looking for n. So this is kind of a work backwards problem. Okay, bye. So n minus 2 times 180 equals 6,120. Now you just solve for n, good old algebra skills. The opposite of multiplying by 180 is dividing by 180. And you get, what, 34? So n minus 2 equals 34. The opposite of minus 2 is plus 2. So how many sides does it have? 36 sides. So we use the formula, we worked backwards. Okay, next one. A regular polygon is given. What's the measure of one interior angle? So now we have a different formula we need to use, right? N minus 2 times 180 divided by n. And it looks like a lot, but I mean, you can just go straight to your calculator. 34 times 180 divided by 36. What do y'all get? It's the same people answering every time, huh? 170 degrees. Are we okay with this? Can we keep going? I'm going to skip number 4 because in a minute I'm going to teach you a way better way to work number 4. So I'm going to skip number 4. Okay. Number 5. What is the measure of the, you want to circle these keywords, sum of the exterior angles of a nonagon. Sum of the exterior angles of a nonagon. Kind of a trick question, right? Okay. 360. What's the sum of the exterior angles of a 50gon? 360. What's the sum of the exterior angles of a 1022gon? 360. Yep. Okay. The measure of one exterior angle is given. What is the name of the polygon? So you always go and you grab a formula. If it's 1 in its exterior, the formula is 360 divided by n. And I know the answer to that problem. I know that that formula equals 9 degrees. So I just need to solve for n. The best way you can do this is put this over 1 and cross multiply. Cross multiply and divide. 360 times 1 divided by 9. What do you get? Y'all are saying 40. Is it a 40gon? That's the name of the polygon. When you don't know the official name, you just write the number and you put gon attached to it. A 40gon. Yeah. Okay. Now I'm going to go back to this one, and since this is the last problem of the day. Okay, unfortunately on this one, one interior angle is given, and we need to know n. We need to know the name. So normally we would set this up and we'd be like, oh, okay, n minus 2 times 180 divided by n, and I know the answer. It's 172.8. Except, that's not an easy problem to solve for n. I mean, you're welcome to try to solve it. You can distribute the 180, you can multiply both sides by n, you can combine like terms, but that is a multi-step problem and you have to feel really confident with your algebra. Instead, you can do a geometry trick. I'm kind of partial. I think geometry is better than algebra. Anyways, you can do a geometry trick. Here's the trick. We know that one of the interior angles is 172.8. But my trick is going to be that I have something up my sleeve. And I know that an interior angle and its exterior angle right next to it form a blank blank. Form a linear pair. Because an interior angle forms a linear pair with its exterior angle, if I know the interior angle, then I know an exterior angle. And don't you agree that the exterior angle formulas are way easier to work with than the interior ones? So instead, I'm going to say 360 divided by some number of sides equals 7.2 degrees. Do you see how I did that? That was tricky, but it's way easier algebraically than solving for the n over there. Okay? Very good, guys. It is a 50gon. I bet that one has a cool name, too. Are you going to look that one up for us? It's a 50gon. Good job. Please do your homework. Get all the way to the back of your homework. Please do your homework. There you go. It's a pentagon. You must memorize all the polygons from 3 to 100. Just kidding.